Okay, Assalamualaikum dan selamat pagi semua. Okay, so pagi ni saya nak bincang sikit mengenai topik 10 ya, wave properties of particle. Okay, topik ni pendek je, tapi soalan dia tu kadang-kadang agak tengoklah kalau yang senang-senang, kalau yang susah-susah ya, kadang-kadang dia agak out of box juga ya. Okay, so kita tengok dulu learning outcome untuk topik ni. Okay, 10.1 kita ada D Broglie wavelength. Okay, state wave particle duality. And then use D Broglie wavelength. Okay, so inilah formula bagi D Broglie wavelength lah. Lambda equal to H over P ya. Okay. Kemudian 10.2 kita ada electron diffraction. Okay. So describe the observation of electron diffraction in division and German experiment. And then explain the wave behavior of electron in an electron microscope. And then relate the D Broglie wavelength of electron with the resolving power of the microscope. Ini konsep sikit lah ya. Alright. And then last kali state the advantages of electron microscope compared to the optical microscope. Okay. So topik ni pun banyak konsep dan teori Banyak konsep dan teori. Okay. Formula pun banyak jugalah untuk topik 10 ni Alright. So kita tengok. Okay. So, chapter 10, wave properties of particle. So, introduction. The photoelectric effect provides evidence that light behaves like a particle. According to the Einstein, light consists of package of energy known as a photon. However, under different conditions, light exhibits wave properties such as interference, diffraction, and polarization. The ability of light to have both wave and particle characteristic is known as a wave-particle duality. So, light ni dia special sebab dia boleh ada kedua-dua karakteristik. Okay. To have both wave and particle characteristic. Okay. Maksudnya light ni dia boleh jadi particle. Dia juga boleh jadi gelombang. So, kita bahas topik ni. Iaitu wave particles duality. Okay. Alright. Okay. So, kita tengok 25.1. The D Broglie wavelength. Apa itu D Broglie wavelength ya. Okay. So, learning outcome yang pertama. Okay. State wave particle duality. Okay. So, wave particle duality is a phenomenon where under certain circumstances, a particle exhibit wave-like behavior, and under other conditions, a wave exhibit particle-like behavior. But we cannot observe both aspects of its behavior simultaneously. Okay, so macam kita tahu tadi, okay, dalam keadaan-keadaan yang tertentu ya, okay, particle exhibit wave-like behavior. Okay. And under condition, a wave exhibit particle behavior. Tapi kita tak boleh tengok sifat ni pada masa yang sama. Dia berlaku satu-satu. Okay. Kalau jadi wave, dia jadi wave. Kalau dia jadi wave dan ada sifat wave, sifat wave. Kalau dia jadi particle, dia ada sifat particle. Tapi kita tak boleh tengok kedua-dua sifat ni pada masa yang sama. Okay. Itu yang dimaksudkan sebagai wave particle duality. Okay. So, kita ada D Broglie wavelength. Okay, use the D Broglie wavelength. So, formula dia adalah lambda equal to H over P. Okay, so ini adalah D Broglie wavelength lah. The equation ya. Lambda equal to H over P ya. Ataupun P equal to H over lambda. So, P ni adalah momentum. Okay, represent properties of particle. So, momentum represent properties of particle ya. Represent properties of particle. Kemudian lambda, okay, represent properties of wave. Okay, maka dapatlah persamaan P equal to H over lambda. The H adalah constant Alright. So, from equation 35.3, so does light have momentum and exhibit particle properties? This is also shows light is dualistic in nature, behaving in some situation like wave and in others like particles, photon ya. And this phenomenon is called wave-particle duality of light. So table 25.1 shows the experiment evidence to show wave particle duality of light lah. Okay. So kalau kita nak tengok sifat wave tu, kita akan dapat tengok daripada eksperimen Young and double slit experiment. Okay. Dan juga diffraction experiment. Okay. Ni kita akan dapat lihat light tu bersifat seperti gelombang. Okay. Light bersifat gelombang. Tapi kalau kita nak tengok light tu dia bersifat partikel, okay, kita tengok pada eksperimen photoelectric effect yang kita dah buat sebelum ni. Dan juga eksperimen ataupun konsep Compton effect. Okay, so ini konsep ni menerangkan bahawa light tu mempunyai sifat partikel. Okay, so based on the wave particle duality of light, so Louis D. Broglie suggested that matter such as electron and proton might also have a dual nature. Okay, so he proposed that for any particle of momentum, P should have a wavelength lambda given by lambda equal to H over P. Okay, P adalah momentum kan? So, momentum P equal to mv. So, jadilah lambda equal to H over mv. Okay, wave lambda adalah D Broglie wavelength. M adalah mass of the particle. And H adalah Planck constant. Dan V adalah velocity of the particle. Okay ya. So this equation D Broglie wavelength. Okay. Alright. Okay, sekarang kita akan tengok satu eksperimen yang dia dah conduct. Okay, 25.2 electron diffraction. Describe the observation of electron diffraction in Davisson and Gemma experiment. So, inilah eksperimen dia, Davisson and Gemma experiment. So, figure 25.1 shows a tube for demonstrating electron diffraction by Davisson and Gemma. Okay. So, a beam of accelerated electrons strike on the layer of graphite, which is extremely thin, and a diffraction pattern consisting of ring is seen on the tube face. So this experiment proved that the D Broglie relation was right, and the wavelength of the electron is given by lambda equal to H over P equal to H over mv. Where lambda adalah D Broglie wavelength, H adalah Planck constant, m adalah mass of the electron, dan v adalah velocity of the electron. Okay, if the velocity of electron is increased, the ring are seen to be narrower, showing that the wavelength of electron decreases with increasing velocity as predicted by D Broglie. So the velocity of electron are controlled by the applied voltage V across anode and cathode. Okay. So inilah di antara formula yang ada yang awak kena ingat juga ya. Dia banyak formula terbitan ya. So U sama dengan K sama dengan EV. EV sama dengan K kinetic energy kan, sama dengan EV sama dengan half mv squared lah. Okay. Kemudian so kita tadi di Broglie wavelength lambda equal to H over mv. Okay. So lambda equal to ini kalau kita dah modify, okay, daripada persamaan ni kita modify jadi V equal to square root 2EV over M. Okay. Alright. Dan okay, from lambda equal to H over MV. Okay, kita substitute nilai V ni. Okay, nilai V ni kita substitute dekat dalam ni kan. Okay, so dia jadi macam ni lah formula dia. Lambda equal to H over M square root 2EV over M. Okay, alright. Dan bila kita dah modify, dia akan jadi lambda equal to H over square root 2 MEV. Okay. So, lambda ni di Broglie wavelength lah. Okay ya. Alright. So, electrons are not the only particle which behave as a wave. So, the diffraction effect are less noticeable with more massive particle because of their momentum are generally much higher. And so, the wavelength is correspondingly shorter. Okay ya. So, ini part yang seterusnya. Explain the wave behavior of electron in an electron microscope. Okay. So, a practical device that relies on the wave properties of electron is an electron microscope. It is similar to the optical compound microscope in many aspects. So in operation, a beam of electron falls on the thin slice of sample. The sample specimen to be examined must be very thin, a few micrometers, to minimize the effect, such as absorption or scattering of the electrons. The electron beam is controlled by electrostatic or magnetic lenses to focus on the beam to an image. So the image is formed on a fluorescent screen. Okay, so there are two types of electron microscope. So kita ada transmission, produce a two-dimensional image, dan kita ada scanning, produce image which are three-dimensional quality. Okay, so figure 25.2 and 25.3 are diagram of the transmission electron microscope and the scanning electron microscope. So ini contoh mikroskop dia lah. Okay, ini adalah transmission electron microscope. So ini adalah scanning. Okay, electron microscope. Okay. Alright. So, state the advantages of electron microscope compared to the optical microscope. Okay. So, in an electron microscope, electrons are accelerated through a high potential difference to achieve very high speed. So, the very high speed correspond to the very short wavelength. As from the de Broglie wavelength, lambda equal to h over mv. Jadi, mv equal to h over lambda. So, when lambda is decreasing, so v is increasing. Okay, the shorter the wavelength, the higher the velocity will be. The very speed. Yeah. Okay. So, the shorter the wavelength, the higher the resolution power. Okay, so advantages of electron microscope compared to the optical microscope. Okay, untuk electron microscope have a very high resolution power because the wavelength of the electron wave can be made very small, which can be thousands of times smaller than the visible light. Okay, this is because the electron can be accelerated to a very high kinetic energy, giving them a very short wavelength lambda, typically 100 times shorter than those of the visible light. So the magnification of an electron microscope can be 1,000 of times better than the optical microscope. Okay, kalau for optical microscope, only a certain range of resolving power can be obtained because the visible light used have a certain range. Okay, so that's why kita banyak menggunakan electron microscope lah, sebab kita boleh tengok benda yang lagi kecil ya. Sebab dia punya resolution power dia sangat tinggi. Okay, alright. So ini adalah beberapa equation yang awak kena hafal lah dan kena ingat untuk kita menjawab topik ini dengan baik. Okay, so kena banyak buat latihan jugalah untuk topik ni. Okay, pertama. Okay, lambda equal to h over p. So since p equal to mv, so lambda equal to h over mv. Okay, persamaan yang kedua. U sama dengan K. K adalah kinetic energy. Kinetic energy sama dengan EV sama dengan half mv squared. Okay, bila kita modify jadilah V, velocity, sama dengan 2EV over M. Okay, alright. Okay, yang ni pula kita modify lagi. Okay, from lambda equal to H over MV. So, V sama dengan square root 2EV over M. So, kita gantikan V ni. Mesti cakap je lah, kita gantikan V ni dengan formula ni. Okay. So, dia jadi H equal to, lambda equal to H over M square root 2EV over M. Lepas tu kita modify, dia jadi lambda equal to H over square root 2MEV. Okay. So, since K equal to EV, modify lagi, dia menjadi lambda equal to H over square root 2MK. Okay ya. Sebab EV ni kita dah tukar kepada K. Kan. Okay. Okay, kemudian E, kita ada E equal to HC per lambda. So, E equal to MC squared. So, since P equal to MV, so E juga boleh sama dengan PC. Dan kalau untuk momentum pula, okay, since P equal to MV, so boleh juga buat P sama dengan square root to MEV. Okay, so ini adalah di antara equation yang awak kena ingat lah dalam topik ni. Okay. Dalam soalan topik ni juga sometimes dia suka keluar buat ratio ya. Okay, buat ratio. Okay, alright. So, jadi teruskan buat tutorial dan juga cuba buat exercise ya. Walaupun dia soalan dia tak banyak sangat keluar. Okay, sebab topik dia sangat sikit ya, simple. Tapi masih lagi sangat penting. Okay, sebab during our final, semua topik akan keluar. Okay, boleh. Alright. Okay, itu sajalah untuk chapter ni ya. Okay. So, okay, itu saja. Okay, terima kasih. Assalamualaikum.